Hi, welcome to Marker Board Videos. This video is about chemical bonding. So what is chemical bonding? Well, it's when you combine atoms to form either molecules or ionic compounds. And we'll talk about the difference between molecules and ionic compounds in just a minute, but that's what chemical bonding is. A chemical bond is the interaction that holds atoms or ions together. So it's what keeps them together. We've talked previously about valence electrons, but I just want to remind you that valence electrons are electrons that are in an atom's outermost shell. So if you remember, we talked about energy levels or orbits or shells and how they fill up usually from the inside and work their way out. Well, the one that's on the outside, the electrons that are in that outermost shell, farthest away from the nucleus, are the ones that are going to be involved in chemical bonding. They're the ones that are going to make up the chemical bond, and they're the ones that determine the characteristics of an atom. So the properties are determined by that valence electrons, the number of electrons that are in that valence shell. So let's do a quick review of this. If I have oxygen, chemical symbol O, it has 8 electrons. Look on your periodic table, same number of the atomic number. The atomic number is 8. That tells you the number of protons. But in a stable, balanced atom, the number of electrons is exactly the same. So that's also 8. And its atomic number is 16. 16 minus 8 is also 8. That tells us our neutrons. So we have 8 protons and 8 neutrons. You have 2 electrons in the first shell and 6 in the outer shell, 6 in the next shell. 6 and 2 makes 8. There's your 8 electrons. Those 6 electrons in the outermost shell, those are the ones that are going to be involved in chemical bonding. Those are the ones that give oxygen its properties. Let's do the same thing for sodium. Sodium's symbol is Na. 11 protons, 11 electrons, and 12 neutrons. 12 neutrons because its mass is 23. 23 minus 11 is 12. So here's my nucleus with my 11 protons and 12 neutrons. First shell I have 2 electrons. Second shell I have 8 electrons. Third shell I have 1 electron. So 1 electron, it's valence electrons. Interestingly enough, if you look on the periodic table, you will find sodium in group 1A, telling you it has 1 valence electron. And oxygen is in group 6A, which tells you it has 6 valence electrons. Now there's 2 magic numbers in chemistry. The most important one is 8. 8. It's called the octet rule. Oct is the prefix for 8. Every atom wants to have 8 electrons in its outermost shell. It wants that, wants that, wants that. Couple of them will settle for 2, like hydrogen, lithium. Those ones that don't have a hope of getting 8 will settle for 2, but everything else wants 8. That's the magic number. Keep that in mind. I'll show you why in just a minute. So the first kind of bond we're going to talk about is an ionic bond, I-O-N-I-C, ionic bond. And that's when electrons are actually transferred. They're transferred from one atom to the other atom. One atom says, you know what, I'm better off without this electron. And the other atom says, great, because I need that electron. Not necessarily just one electron gets transferred. Sometimes it's more than one. Usually, step back. An atom is going to gain or lose an electron in order to get 8 electrons in its outermost shell. So looking back at these two, oxygen has 6. It can either give up 6 or take 2. What's easier? Well, 2 is easier than 6. It's going to take 2. Sodium. Sodium can give up 1 or it can take 7. What's going to be easier? Giving up that 1. And look, when sodium gives up the 1, it has 8 now, doesn't it? It's going to either give or take to get that 8. Again, it'll settle for 2 if it has to, but just those low number atoms. So it's going to gain or lose electrons in order to get 8 electrons in its outermost shell. Usually it's a metal and a nonmetal. If you don't remember that, nonmetals are up and to the right on the periodic table, right around here. Metals are this whole big thing right in here. Okay. If you give up an electron, if you lose an electron, giving, the way I remember it is giving, it's very good to give, it's very positive. So if you give an electron, you have a positive. Well, that makes sense, because if you had 6 plus charges and 6 minus charges, and you give one of the minuses up, now you have 6 plus and 5 minus, you're left with a net of positive. So keep in mind, giving is very positive, taking is very negative. We have special words for atoms that give or take electrons. They're called ions, but specifically, if you give an electron, you're called a cation. If you take an electron, you're called an anion. Easiest way that I found to remember that, look at this little T in the word cation. That looks like a little plus sign. That means it's positive. That means it's giving electrons. That N in the word anion, N is for negative. Negative means it's taking electrons. So that's an easy way to remember cations and anions. So here's an example of what I'm talking about. Let's break this down. First of all, sodium chloride. Sodium's a metal, chlorine's a nonmetal. It's probably going to be an ionic bond. Let's take a look. Sodium has 11 electrons. It's in group 1A, so I have 1 valence electron. This is sodium right here. 11 and 12, 2, 8, and 1. That makes 11, right? Chlorine has 17 electrons. It's in group 7A, so I'm going to look for 7 valence electrons. And I have 17 and 18. I have 2, 8, and then in the outer shell, I have 7. So there's my 17. Now what literally happens, and you know sodium chloride is a very stable compound. It's table salt. We use it all the time. We have it all the time. Sodium says, you know what? I can do without this 1 electron. If I didn't have this 1 electron, look, I'd be happy as a clam because I'd have 8. Chlorine says, really? Because I need 1. So would you please just give me your 1? So sodium says, sure, here's my 1. Chlorine now has 8. Sodium now has 8. They're both happy. But sodium has now more positives than negatives. It's going to have a positive charge. Chlorine has more negatives than positive. It's going to have a negative charge. And remember way back when we talked about magnetism and opposites attract? Well, a negative and a positive want to stick together, and that's what they do. They stick together. If you're doing an electron dot diagram, this is what it looks like. If you're not doing an electron dot diagram, don't worry about it. Electron dot diagrams, you only look at valence electrons. Chlorine has 7, as shown with the blue dots right here. Sodium has 1, as shown with the green X right here. If you look at this, sodium has 8 now. I'm sorry, chlorine has 8 now. And sodium looks like it has none, but it really has 8 in its outermost shell. So let's talk about nonmetal and nonmetal. Well, when you have a nonmetal and a nonmetal form a bond, that's called a covalent bond. And it's when electrons are shared. Now, I don't know if you ever had to share your bedroom or not. When I was a kid, I grew up in a 3-bedroom house with 3 sisters, my mom and dad. So there were 6 of them in the house, 4 girls. We had to share a bedroom. Now, if you asked me whose bedroom it was, I would tell you it was mine. If you asked my sister whose bedroom it was, she would tell you it was hers, and she was kind enough to let me use it. If you asked my parents, they would say that we share. And that's kind of what happens with a covalent bond. The atoms don't know that they're sharing. They think they have what they need, but indeed they are actually sharing. Covalent bond, when you have things that form a covalent bond, the thing that you get is called a molecule. It's usually 2 nonmetals, so things in the top right of the periodic table right here. And we usually talk about pairs of shared electrons. And there can be more than 1 pair that is shared. So let's try methane, CH4. Carbon has 4 electrons. Hydrogen has 1. But you see when you count atoms, I have 4 hydrogens. So I actually have a total of 4 electrons to work with. 4 from carbon, 4 from hydrogen gives me 8 electrons total. And again, if I want to draw that out, I'd have a carbon with my 8 electrons around it. Now, if you look at each hydrogen thinks it has 2. Remember, hydrogen's happy with 2. If you look at carbon thinks it has 8. It wants 8. But each one of these thinks it has exactly what it needs, and it does. But in reality, it's sharing. It's not giving or taking. Now, remember how a minute ago I said we're talking about pairs of shared electrons? If you share 1 pair of electrons, that's called a single bond. Kind of like hitting a single in baseball, 1 base. A double bond, then what do you think? If a single bond is 1 pair of shared electrons, a double bond is, 2 pairs of shared electrons. Triple bond would be 3 pairs of shared electrons. Just like a triple in a baseball game, you get to go on 3 bases. It's kind of how I remember it. But again, we're talking about pairs of shared electrons, not individual shared electrons. So we did metal and nonmetal. We did nonmetal and nonmetal. What's left is metal and metal. But before we get there, let's do a quick review, okay? So ionic bonds is with a transfer of electrons. If you gain or take electrons, that's negative. That's called an anion. If you lose or give electrons, that's positive. That's called a cation. Once it gives or takes electrons, it's no longer an atom. It's now called an ion. Okay? This generally is for a metal and a nonmetal. Covalent, sharing of electrons. The thing that you get is a molecule, and it's usually a metal and a nonmetal. With metal plus metal, we have a special thing called a metallic bond. We're not going to talk about it in this class, but I want you to be aware of it. There's other kind of bonding as well. There's hydrogen bonding and stuff like that. Again, outside of the realm of this course, but I want you to be aware that there are other kinds. But the ones I want you to focus on are ionic and covalent. Make sure you totally understand the difference between those two. One's sharing and one's giving and taking.